Final problem of this course, which is problem 16-121, and you can expect a problem of this sort in your final exams as well. Okay, again you have a rigid body mechanism in which we have a link AB, the crank, which is rotating with an angular velocity of 6 radians per second and an angular acceleration of 2 radians per second square, both directed in a clockwise direction. So this crank AB is rotating in a clockwise direction with this much of kinematics. You are asked to determine the acceleration of point C, which is constrained to move within the curved path shown to you, having a radius of 150 millimeter. You also need to find out the angular acceleration of this connecting rod. Since omegas are not given to you, so first of all, again, आपकी एक तरह से revision हो जाएगी. We need to perform the velocity analysis, and then we are going to determine omega BC from that analysis, and then we are going to use that omega in order to perform the acceleration analysis. So velocity analysis हमने शुरू करनी है. किस लिंक से हम उसको स्टार्ट करेंगे?
लिंक AB.
Link AB से start करेंगे. So in order to find out the velocity of point B, since link AB is in pure rotational motion with respect to point A, so VB should be equal to omega cross R, where omega is the angular velocity of this link AB and R is basically the absolute position vector RB. Now since this link is already given to us rotating in a clockwise direction, so we are going to put its correct value, which is minus 6K because of that clockwise rotation. अब आपने assume नहीं करना, जो चीज आपको given है उसको आपने उसी form में लेना है. So it is going to be minus 6K cross RB. So what is this vector RB?
Vertical 300 millimeters.
So vertical है 300 millimeter, positive, negative?
Positive, upward.
Upward. So it is going to be 0.3J. So once you take this cross product, what is K cross J?
Negative I.
Negative I, so negative positive हो जाएंगे, and it would comes out to be 1.8 I. So B is going to be 1.8 I. Okay, moving on to the next link. Which is the next link at which we are going to move?
BC.
Sir, ये link BC.
It is the connecting rod which is link BC. So what should be our base point?
B.
Link B. Sorry, point B.
So we are going to write the relative velocity equation, which is VC equal to VB plus omega cross R. Now omega is going to be omega BC, which is the angular velocity of this link, and R is going to be the relative position of C with respect to B. Okay, if we take a closer look at the motion of this link, since point B is in pure rotation with respect to point A, so at the very next instant, probably link B is going to be a little downward. जो कि circle cross कर चुका है, it is going to be a little downward. Similarly, link C is going to be at this point. So probably the next position of this link is shown to you as this red line. So what do you think the direction of rotation of link BC, angular velocity इसकी clockwise है या counter clockwise है?
Sir, clockwise है. Counter clockwise.
दोबारा और कर.
Counter clockwise, sir.
Okay, थोड़ा सा इस डायरेक्शन और से देखें.
Clockwise.
Clockwise है.
Clockwise है.
No, sir.
चलें
Counterclockwise.
नहीं है ये clockwise ही, लेकिन एक काम करते हैं. Let us assume it in a counterclockwise direction. Although मुझे नजर आ रहा है कि clockwise है, लेकिन let us assume it in a counterclockwise direction and let us solve it. If its sign comes out to be positive, assumption correct हो जाएगी. Sign negative आ गया तो मैं अपनी assumption को reverse कर लूंगा. Is this point clear to all of you? Although मुझे नजर आ रहा है clockwise है, लेकिन चलें just समझने के लिए मैं इसको counterclockwise assume कर लेता हूँ. ठीक है?
Okay, sir.
What about this vector RCB, the relative position of C with respect to B? कौन सा quadrant है?
Second quadrant.
It is second quadrant, so positive x, negative y, angle is 30 degree, so 0.5 cos 30i minus 0.5 sin 30j, वो आपका वेक्टर हो जाएगा.
उल्टा नहीं होता ये x
Fourth
axis negative y axis positive.
फोर्थ क्वाड्रेंट
Yes,
में
sir.
पॉजिटिव x नेगेटिव y.
Yes, sir. Why?
Fourth quadrant, right?
So 0.433i minus 0.25j, ये आपके पास पोजीशन वेक्टर r आ जाएगा, रिलेटिव पोजीशन वेक्टर. ठीक है.
Yes.
Okay, so once you take this cross product, the right hand side would become 1.8i. The first term is 0.433 omega bc, k cross I is j, so the first term would be equal to j. The second term would be minus, sign मौजूद है, 0.25 omega bc and k cross j is minus I, so ये minus minus plus हो गया और आपके पास राइट साइड पे ये चीज आ जाएगी. ठीक है, क्रॉस प्रोडक्ट कर लेंगे आप इस तरह.
Yes, sir.
Okay, coming towards the left hand side, what does that left hand side indicate?
Velocity of C.
Velocity of c, since point c is constrained to move within a circular path, so the velocity in case of circular motion is tangent to the curve. So what should be the direction of velocity in this case?
VC equal VCJ.
So Vc should be equal to minus Vcj. So putting the value of Vc to be equal to minus Vcj and then comparing the I and j coefficients on both sides of this equation. So once you compare the I coefficients, आपके पास 0 to be equal to 1.8 plus 0.25 omega Vc आ जाएगा. From here you can see clearly that the value of omega comes out to be negative quantity. That negative quantity says that our assumption regarding omega, which was counterclockwise direction, was incorrect. Rather, this omega is rotating in a clockwise direction. ठीक है, क्लियर है ये चीज?
माइनस जे क्यों लिया है सर VC के साथ?
देखिए आपके पास ये इस तरफ लिंक जा रहे हैं ए बी ना क्लॉकवाइज डायरेक्शन. सो एट द नेक्स्ट इंस्टेंट, जिस तरह मैंने कहा था, अगर हम नेक्स्ट इंस्टेंट बनाने की कोशिश करें, ये सर्कल में मूव कर रहा होगा ना पॉइंट बी, तो इसका मतलब है अगले इंस्टेंट पे ये थोड़ा सा नीचे आ चुका होगा पॉइंट बी.
यस सर.
अकॉर्डिंगली पॉइंट सी रिजिड बॉडी है, डिफॉर्म तो हो नहीं सकती. पॉइंट सी जो है वो इस तरफ मूव कर गया होगा, तो एक तरह से पॉइंट सी जो है वो डाउनवर्ड मोशन कर रहे हैं, इसलिए हमने उसको माइनस VCJ लिख लिया था.
सर इसको एज्यूम कर सकते हैं?
देखिए डबल अजम्पशन ना करें, कोई एक चीज आप अज्यूम कर सकते हैं.
और सर ये बी पे पिन जॉइंट नहीं लगा था?
बिल्कुल पिन जॉइंट है.
तो फिर सर तो सी तो मतलब अगर पिन जॉइंट है तो सी तो ऊपर मोशन फिर कर रहा है.
ऊपर कैसे कर रहे हैं? देखिए ये आपका सर्कल है जो कि पॉइंट बी बना रहे हैं. येलो से नजर आ रहा है वो सर्कल?
यस सर.
अब देखें ये लिंक किस डायरेक्शन में जा रहा है? क्लॉकवाइज डायरेक्शन में ए बी जो है. तो अगले इंस्टेंट पे पॉइंट बी कहाँ होगा? इस जगह नहीं होगा?
जी बिल्कुल. तो
इस जगह अगर होगा तो रिजिड बॉडी मेंटेन रखने के लिए पॉइंट सी को हर हाल में नीचे की तरफ आना है. ठीक है, पॉइंट सी ऊपर जा सकते हैं वैसे
अगर काउंटर क्लॉक मोशन हुआ ए बी की.
नहीं, अगर हुआ, लेकिन क्लॉकवाइज ए बी कर रहे हैं, तो क्लॉकवाइज ए बी करने के नतीजे में वो रिजिड बॉडी डिफॉर्म होगी तो पॉइंट सी ऊपर जाएगा, अदरवाइज पॉइंट सी ने नीचे जाना है. और रिजिड बॉडी चूंकि डिफॉर्म नहीं हो सकती, लिहाजा सी पॉइंट ने नीचे की तरफ मूव करना है, इसलिए हमने उसको VCJ के बजाय माइनस VCJ लिखा है. ओके, सो द साइन ऑफ VC कम्स आउट टू बी पॉजिटिव. इस पॉजिटिव साइन का क्या मतलब है? कि हमारी assumption regarding point C correct है and point C is basically traveling downward. So VC आपके पास downward motion कर रहे हैं. Okay, so once you have completed this velocity analysis, let us now move on to the acceleration analysis, because we were asked to determine the acceleration of point C as well as the angular acceleration of this connecting rod. So in order to start this acceleration, we are again going to start from point B, but since point B is doing circular motion with respect to point A, so what should be the acceleration vector AB with reference to link AB? Point B is in pure rotation with respect to point A. So acceleration क्या होगा? Alpha cross R minus omega square R, where alpha is going to be the angular acceleration of AB, omega is going to be the angular velocity of AB, and R is basically the absolute position vector, that is vector position of point B with respect to fixed point A. So alpha cross R minus omega square R, again alpha is given to you as 2 radians per second in a clockwise direction, so you are going to write it as minus 2k cross 0.3 I, इसी तरह minus omega AB, which is 6 square and 0.3 I. So this would become 0.6 I minus 10.8 J meter per second square. So this is going to be the absolute acceleration of point B. Clear है यहाँ तक?
Yes.
Okay, the next link to which we are going to move is the connecting rod. So we are going to make point B as our base point. The equation would become acceleration of C to be equal to acceleration of B plus alpha cross R minus omega square R, where alpha is now the angular acceleration of link BC, omega is going to be angular acceleration of link BC, and R is going to be the relative position vector, relative position of C with respect to B. AB आपने इससे पिछले स्टेप में ऑलरेडी डिटरमिन किया है, which is 0.6 I minus 10.8 J plus alpha, again alpha आप assume करेंगे in a counterclockwise direction cross R. R आप ऑलरेडी फाइंड कर चुके हैं इससे पिछले उस केस में, which is 0.433 minus 0.25 J, ये आपके पास I था, माइनस ओमेगा, ओमेगा आपके पास आ गया था 7.2, so 7.2 स्क्वायर मल्टीप्लाई बाय दिस R, ये आपके पास ओमेगा स्क्वायर R हो जाएगा. So once you take this cross product, आपके पास right side complete हो जाएगी. Coming towards the left hand side of this equation, the left hand side of this equation represents the absolute acceleration of point C. Since point C is in pure rotational motion, so this AC vector would comprise of two components. The first one is the tangential component of acceleration. The second one is the normal component of acceleration, and the total acceleration AC would be equal to the vector sum of its two components. Okay, coming towards this normal component, ACN, magnitude क्या होगा इस ACN का? V square by R, और V हम already इससे पिछले step में find कर चुके हैं that V was basically 3.118, so it is going to be 3.118 square over R. What is R here?
150 millimeter.
So it is going to be 0.15 meter. So V square, which is 3.118 square divided by 0.15, ये उसका magnitude हो जाएगा. अगर हम इसके direction की बात करें, तो in which direction this normal component would be acting?
Sir, towards the positive x-axis.
So towards the center, which is towards the positive x-axis. So we can write this vector as V square over rho I. Is it clear to all of you?
Yes, sir.
Okay, coming towards the second component, which is ACT. Although we don't know the magnitude of this tangential component, but as far as our understanding is concerned, tangential component किस direction में act करता है?
Tangent to the curve.
Tangent to the curve. So tangent to the curve आपकी कौन सी axis बनती हैं?
Y-axis.
Y-axis. So we can write it as minus ACT J. So overall, the vector AC would be equal to V square over rho I minus ACT J. Clear है ये चीज?
Yes, sir.
Okay, so now comparing the I and J coefficients on both sides of this equation. So once you compare the I coefficient, आपके पास जो equation आएगी वो ये वाली equation होगी. Once you compare the J coefficients, you are going to get this equation. So solving these two equations would give you the value of alpha, which is the angular acceleration of this connecting rod, to be equal to 346.6 radians per second square. And since this value comes out to be a positive quantity, it means that your assumed direction of alpha is correct. Finding the value of ACT, this ACT comes out to be a negative quantity. What does that mean?
Deceleration.
It means that the tangential component of acceleration is acting upward, isn't it?
No, sir. Decreasing acceleration, sir.
देखें आपके पास वेलोसिटी जो है वो इसकी आई थी डाउनवर्ड डायरेक्शन में, जो हमने पहले स्टेप में फॉलो की थी. The tangential component of acceleration is opposite to the direction of velocity. What does that mean as far as the curvilinear motion is concerned?
Retardation.
Velocity के magnitude में क्या हो रहा है?
Decrease.
Decrease आ रही है. So that's why आपके पास tangential component जो है that is opposite to the direction of velocity आया है. Is this point clear to all of you?
Yes, sir.
Because the tangential component of acceleration किसको represent करता है? अगर हम chapter 12 की understanding पे जाएं, the tangential component of acceleration basically represents the rate of increase or decrease in the magnitude of velocity. So if the velocity's magnitude is increasing, then ACT and V are going to be in the same direction. However, if the direction of tangential component is opposite to the direction of velocity, then it means that the particle is the magnitude of velocity is decreasing. ठीक है, ये समझ आ गई ये बात हर एक को?